Okay, welcome back. Let's do the memo for practical 3 now. So it's just a continuation of the previous practical. So we need to modify practical 2 as follows. So we need to remove the sensor ID from the record structure. So let's do that. Go to the header file and remove the sensor ID. There we go. Remove the sensor ID. Add a new variable of type bool to the IIoT sensor, representing whether the sensor is active. So we need to add an extra variable to the structure that represents whether a sensor is active or not. So when an IoT an IoT monitor object is created, every sensor must be set to active. So we're going to change that, but let's start by adding the is active variable to our record structure. So here I'm going to change this to a bool and then change that to is active. So this is a variable that's going to help us know whether a sensor is active or not. So I'm just going to call it is active. So since we're not going to use the sensor ID, we're going to have to change our code in our constructor. So let's go to our constructor. Um, okay, that's fine because the way this is how we're calling it like this. So that's fine. So by default, let me see. Does this mean that I have to create it? Let's see. So you add that new variable that represents whether the sensor is active. So when an IIoT monitor object is created, every sensor must be set to active. So when I create the object, I must set the sensor to active. But I don't have to worry about that because, oh, okay, so I have to set it to active. So that means in terms of my context expression IoT sensor, remember I was taking in an ID first. So by default, it's going to be true, right? I'm just going to set it to true for all of them by default. And then I'm going to use that variable. And then here, even when I'm setting it from getting the value from the user, I'm gonna take it as I'm gonna use true. Yeah, because that's part of the requirements. So I think that's fine. Yeah, that's fine. We don't have to worry about that. That's all we had to change. Because remember, here I'm using default sensor here. So if I check in my main, I'm only using the default constructor here. And by default, it's set to what? It's set to true as a practical requirement. Something new. Okay. So the range of the light intensity, it now changes. So it's now between 10,000 and 30,000. So now it changes. It's no longer 0 to 200,000. It's 10,000 and 30,000. It's between that range now. That means even my constants, I need to fix them. The light, it's not going to start from 10,000 to 30,000. 30,000. So that you see, that's the nice thing with having constants. You don't have to change every single part of your code. You just change once. And then they say I should create a class. So let's create the class called IIoT scanner. And remember what he said. Every class is going to have two files, a header file for its logical properties and a implementation file, which basically has the implementation. That's self-explanatory. And the header file must be named exactly the same way you're going to name your class, right? Add both the header file and the implementation file. So I'm going to have the header file and I'm going to create the source file. .cpp. That's the source file because we're using C++ as our language. Then I'm going to say hash include IoT scanner.h. I'm going to implement that later. So let's implement our class. Let's see what they want us to create. So this class includes a public void. You see, public, then void. So they're giving us all the information that we need. So a public void scan method, right? So let's do that. So public, then it's gonna be void scan. It's a scan method. It takes in an IoT monitor reference, right, as input. So I'm just gonna make it a signature function. So remember we did references in the previous practical solution. So yeah, you're just gonna add the ampersand there to signify that I'm gonna pass it by address. I'm not gonna take the whole size of the object. I'm just gonna get its location. Where is it located? What is its address? I'm just gonna get the address. So in terms of the const, whether it needs to be included or not, it depends on what operations we're supposed to do. So this member function must loop through all the sensors in the array. And then if it must set, you see, this is where the keyword, the keyword I was looking for is the keyword set. That means I'm changing. It's mutating. So I shouldn't put the keyword const. If I put const, it's gonna complain because at the end of the day, I'm gonna update this object. So since I want to update the object, I won't put the keyword, the prefix const. I won't put it there. So yeah, we're done declaring. We haven't gotten to the implementation part. We'll get to that. So this IoT monitor, it should have a you should have a reference or should have a IoT scanner class. So we're doing composition basically here. So I need to have IoT scanner whose life cycle it manages directly. This is composition. There's a life cycle dependency. So basically what that means, it means that one object cannot exist without the existence of the other object, or the one class cannot exist without the existence of another class. Any way you want to put it, it means the same thing. So since I'm managing its life cycle, I'm going to make it a pointer so that I can allocate. So that I can instantiate, not allocate. I can instantiate the object and uh, you call the destructor to delete the object, basically. So let me do that. And as you can see, it says that it must be managed from essentially from the free store. So when the IoT monitor is created, so that means in the constructor for IoT monitor, that's where you should instantiate it. And then deallocated, you need to deallocate it when the IoT monitor is destroyed. So let's do that. So let me create the IoT sensor. No, what is this? Scanner. Make it a pointer because its life cycle is being managed by IoT monitor. So I need to make it a pointer so that I can use the what. Remember that everything that we use the new keyword as a point, so that I can use this new keyword, so that I can allocate memory for it because it says that its life cycle is being managed by the IoT monitor. So I'm gonna call it scanner like this. but it doesn't know what scanner is. So if you build it, it's going to complain. So okay, yeah, okay, let's start here. It's complaining because it doesn't know what IIoT monitor is. So I'm going to say hash include the IIoT monitor header file so that it knows what I'm talking about when I say IIoT monitor. And then the same thing happens here with IIoT scanner. As far as it concerned, you are just taking chances. You're just basically being spiritual. You're just doing things that are just not ordinary or not normal. So it's like, okay, what do you mean by IoT scanner? What do you mean by that? And then it even tries to help it. Do you mean IoT sensor? Because the only thing that has the prefix IoT and that can be used as a data type is the record structure. That's the only thing it's aware of. But no, once I include the scanner header file, it will know what I'm talking about. And then it will stop complaining. And then now it starts complaining about, it's still complaining, right? You'll be wondering, why is it still complaining? Because the way I'm using it, right? Remember, only the only thing that I defined is just a header file. Basically, by hash include, you're just copying and pasting, but in a sense, you're saying, go to this header file, you'll find what you're looking for, right? So at this point in time, within this file, there's nothing that explicitly tells it that this IoT monitor is the type, right? So it doesn't know if this what you're trying to do is possible because it's not aware of IIoT monitor yet. It'll still go there to the header file and find it and see it. But what we need to do right now, we need to do what we call a forward declaration to like make a promise that I promise I know what I'm doing. This is a type. What type is it? It's a class. So it's an IoT monitor class. I am aware of what I'm doing. It's a class. So I'm gonna do forward declaration. So that stops complaining. Even in the IoT monitor class, it's gonna complain about the IoT scanner. It's gonna have this very same issue. So in order for me to avoid that, I need to explicitly tell it what IoT scanner is by doing a forward declaration. Forward declaration is like, okay, I promise you, you'll find out that this is actually a class in the future. I will provide its implementation, but just for now, the only information you need to know is that this is just a class. So forward declaration. So for now, you just need to know that this is just a class. I will provide implement more details later. And it's complaining about sensor ID because it's it's not there anymore. So remember that by default, they said you should set it to true. So I'm just going to set it to true for all of them because by default, that's what the practical requires. So it's set to true. And then, yeah, before we continue, I don't see talking about anything about, what is it, anything about um, the changes that we need to make. But yeah, remember we're using different ranges now. For example, for the intensity, it's no longer from 0 to 200,000. It's now from 10,000 to 30,000. So I need to change that. And then, yeah, the rest is fine. This is true, which is perfectly fine. So we're done with that. Now we need to get to the scan composition part, scan method and all that. So let's see whose life cycle it manages, right? We still haven't implemented this. So let's implement it. Let's manage this life cycle. So the way you manage its life cycle, the scanner's life cycle, remember what we've called it. We called it a scan. So that means by managing its life cycle, it means that whenever you create an IoT monitor, so in the constructor, when you're constructing it, when you're creating the object, also create an object for the IoT scanner. That's basically what it's saying. So I'm just going to say scanner is equals to new IoT scanner. Then this is life cycle management. So I'm managing its life cycle. And then in the destructor, I need to do the very same thing. Deallocate the object. And then also make it point to now. Same thing. Okay. Yeah, I need to make it point now because remember, I'm using a pointer. So I also need to set it, make it point to now point. So build, it's running perfectly fine. So we have manages life cycle. So this part is still life cycle management. And then this part is also still life cycle management. Management. Okay, let me remove this. So let's continue. We have delved to this part. We're done with that. So remember, we are in the what? The IIoT monitor. We are updating the IIoT monitor. So the IIoT monitor, it has also a scan member function. So it has a member function. I need to come here and edit. So I'm gonna say void scan. Yeah. And which it delegates to its contained IoT scanner. So basically what it's saying that its implementation, it won't be provided by IIoT monitor. It'll be provided by IIoT scanner. For example, dedication works perfectly fine when, for example, you just want to divide the functionality. So for example, you don't want one class doing everything. So you want to create classes that specialize in one thing. So for example, the IIoT scanner, it's a scanner class. It specializes in scanning. So what this class is going to do is going to delegate its implementation to the IIoT scanner class because that's the one that's very good with scanning. So it's going to delegate the task. How do we do that? Remember, we have the object, we have composition, right? We have the object. So I'm going to use that object, that pointer, and then access that scan method that we've previously defined. Remember, we defined it in the IoT scanner, and there it is. It's highlighting, showing me what it takes in. It takes in an IoT monitor reference. So in order for me, remember that this function requires a parameter. If you check, if you go to IoT scanner class, it requires what? Parameter. It requires an IoT monitor reference, right? So how do we do that? So we use the keyword this. Remember that this operator. This operator, it basically represents the current instance, right? It represents the current instance. So it returns a pointer to the current instance. So it points to the current instance.